Okay, so like I said, we just kind of started talking about like what these things are. We hadn't really got into anything, but we had a few extra minutes on Friday. So, hey, Natasha, can you close that door? Thank you. Um, what was I going to say? So yeah, sample space, every possible outcome, anything that could possibly happen, right? Anything that could possibly happen when something when when something happens, any possible outcome is called a sample space. So sometimes I'll have you say, how many are in the sample space? Sometimes I'll say, what is the sample space? So for example, there are 36 outcomes in the sample space. Listed are all of those, everything in the sample space. So anytime they say sample space, it's everything that could possibly happen. In this case, it's when you roll two die, right? And then we talked about what happens if you flip two coins, regular coins. Well, there's four things that could happen, right? This is the sample space here. There are four things that could happen. I could get a heads and a heads. I could get a tails and a tails. I can get a heads first and then a tails next. Or I could get a tails and a heads, right? So that's what they're talking about with the sample space. Okay. Probability model is a table. It looks like this. It tells you what are the things in the sample space, what are the things that could happen, and what's the probability of them happening. So what's the probability of me getting, if I'm flipping two coins, right? Probability of getting zero tails, one tail, two tails, both. We have the probabilities there, right? And that's kind of where we stopped. An event is anything that can happen. Okay. Sometimes there are multiple events. Sometimes there's only one event. Okay, so here we go. So these are the rules of probability. This is where we're gonna, for this chapter, where we're gonna be. A lot of these, they seem a lot more complicated than they really are. Like the first one. The first one says for any event, the probability, so like for event A, the probability of it happening is from 0 to 1. Means it can't be a negative probability and it can't be over 100%, right? Has to be something in between 0 and 1 as a decimal, or 0 and 100% as a percent, right? That's all it says. Kind of common sense, right? Number two is kind of common sense too. What is the probability? The probability of the sample space is always going to be one whole. So what does that mean? Well, that means this. Watch. Let me erase these first. That means if I truly have the sample space in front of me, what's the probability if I roll two die that one of those things happens? Yeah, it has to happen, right? If I truly have the sample space, there's nothing else that could happen. So if I really have them, if I don't, then that means I'm missing a couple, right? If the probability is not 100%, that means there's something missing there. But that's everything that could happen. So if I roll two die, the probability of one of those things happening in the sample space is 100%. It has to, because otherwise there'd be something missing, right? And it wouldn't be a sample space. That's what that one says. That's what the second one says. The second one right here. Kind of a fancy way of saying that. The third one, we've talked about this before. How do you find probability, right? How did we know that if we flipped a coin, the probability of a heads is 1 out of 2? You guys kind of said that, right? You said the number of outcomes, heads, over the total number of things that can happen, right? One heads, total number of outcomes, one heads, two things that could happen, a heads or a tails, so 1 out of 2. Okay, that's how to find probability. What's the probability I roll a die and it lands on a 6? Because there's only one 6 on the die, right? And there are 6 different numbers on there, right? Okay. Now we talked about this. We talked about like if I roll a die 6 times, should I get a 6 just one time? Very remember unpredictable in the early. But if I rolled the die 1,000 times, 5,000 times, 1,000,000 times, it would be about 1/6. It would be 1/6. Okay. The complement rule. The complement rule is just everything. So so how do I explain it? What's the easiest way to? It's so if I say the probability. See, if I flip one coin, let's say I flip one coin, the probability of heads is 50%, right? Or 0.5, right? The complement would be everything else that could happen. So if it's not heads, what is it going to be? So I could write it like this. That means what is the probability that it's not going to be heads? Well, in this case, there's only two things that could happen, right? So this is another way of saying tails, right? Let me write it a different way. Let's talk about a die. What's the probability that I roll a 6? We said 1/6, right? What if I change it like this? The probability what that means with the C means is what's the probability that I don't roll a 6? So that'd be 5 out of 6, right? Well, what this says is the probability of this will always be 1 whole minus whatever this is. Okay, so anytime you see that C up there, it means not that, right? Not that. That's what that means. That's the complement rule. So anytime you see this C here, it means not A or whatever that is, right? So it's kind of the opposite of A. What's the probability of A not happening? Okay. And then the last two are the big formulas we're going to use. Actually, no, the next three are the big formulas we're going to use. Okay, so the formulas, there's 3 formulas we're going to use a lot. Addition rule. So we use symbols a lot in math. You guys know that because we don't want to write the words. What does that U mean? Anyone know what that U means in math? Close. This one means and, right? Or, there you go. All right. Or, one or the other. You're close. You had a 50% shot. Okay. So if you see a U, it means or. So what does or mean? A or B. One can happen. The other can happen. Can they both happen? That's okay. That's okay. One or the other or both. That's what that means, right? Or means A can happen, I'd be okay. B can happen, I'd be okay. They both can happen and I'd be okay. Right? How is and different? They both have to happen. Yeah, they both have to happen. A and B have to happen. Okay? Or means one, the other, or both. And means has to be both. No other option. So which has more options of being? Which would we think which makes sense to have a bigger probability? Or and? Oops. Okay. What was it? Isn't it have more leeway? One, the other, or both? And only has both of them have to happen. Right? It has both of them happens. Right? What's the probability of you getting an A in English class versus you getting an A in foreign language? Right? Or means I can get an A over here, or I can get an A over here, or I can do both. Right? Gives you a lot of leeway. And means nope, I have to get an A here, I have to get an A here. Right? Probability goes down. Right? That you do that. So and is more restrictive. And is more restrictive. Okay, so let's go back to or. Or, so if A and B are mutually exclusive. We're going to talk about what mutually exclusive means. That means the probability of A or B happening, I take the A's and I add it with B. So I find the probability of both, add them together. What does mutually exclusive mean?
They can't happen at the same time.
There you go. Can happen at the same time. Two events that are mutually exclusive. You having period 7 AP stats and you having period 7 English class. Those are mutually exclusive events. Why?
They can't have two separate ones.
You can't have two different classes at 7. You can't be in two different places at one time, right? So mutually exclusive means can happen at the same time, cannot happen. What's the probability? Or like, for example, you getting an A in this class and a B in this class. Probability of you getting an A. Probability of you getting a B. Mutually exclusive events. Why? Can't get two grades. You can't get two grades, right? You get one grade for this class, right? Those are mutually exclusive. Cannot happen at the same time. So if A and B can't happen at the same time, to find the or, you add them together. Okay. The next one, multiplication for independent. Independent means one has nothing to do with the other. We'll talk more about this later in the week, independent events, but one has nothing to do with the other. Just because one thing happens doesn't mean another thing's going to happen. Like, for example, if I take a coin and flip it, what did we say the probability of heads was? 50%, right? Let's say I flip it and I get a heads. What's the probability I get another heads? What's the probability I get another heads? So just because I keep getting heads, does that change the probability of me getting heads on the next one?
No.
Doesn't change, right? We say flipping a coin is independent or is an independent event because it doesn't affect the next thing. Okay. Let's say I have cards. So let's say 52 cards, right? 52 cards. So what's the probability that I pick a 2 of diamonds? 1 out of 52. There's 1 2 of diamonds in here and 52 total. So let's say I pick a card. Oops, that's not a card. Whoa, I didn't even do that on purpose. Let's say I pick a card. Right? I put that to the side. Now what's the probability that I pick a 2 of diamonds?
1 out of 51.
1 out of 51, right? Because I did not replace, they are not independent anymore. Because what happened? It went from 1 out of 52 to 1 out of 51, right? Those are dependent events. Dependent, because one affected the other. One affected the probability of the other, right? I can go buy a lotto ticket when I get home. That was crazy. Okay, that's the difference between independent and dependent. Okay. All right. These rules go with the rules we just talked about. These rules are the rules we just talked about. Go with them. General multiplication rule and general addition rule. They're just different forms of that. Right? So the general multiplication rule, we're going to talk more about we're not going to talk about general multiplication rule today. We're going to talk more about the general addition rule. We will go over this. You see all the, it talks about conditional. Conditional means things have already happened. Given that something already happened, what's the probability of this happening? Given that I studied, what's the probability to get an A on this test? Right? That's the kind of thing. We'll talk about that later. The one I want to focus on today is the general addition rule. It kind of looks like the addition rule for mutually exclusive events, right? What's the difference? Look at this one here and look at the general addition rule and what's the difference? It's got a subtraction at the end, right? Yeah. This one right here does not have a subtraction. This one right here does not have subtraction, right? This one over here does have subtraction. So why does it have subtraction? Why does one have subtraction and one doesn't? Well, if things aren't mutually exclusive, they might share something in common, right? What's the probability of you having 6th block PE, you having 7th block history class? There are going to be more than one person who has those things happen, right? There's going to be more than one person. It can happen, right? They're not mutually exclusive. When we have situations like that, we have to include the minus at the end. The minus in the end is for overlap, because if you have 6th period PE, you're in here. If you have 7th period history, you're in here. What if you have both? You're in here and in here. Should we count you twice? Nope. So we subtract you once because you are in both, right? Everyone should only be represented one time. People shouldn't be represented more than one time, or else it's not true, right? That's what the general multiplication rule says. And this is the one we're going to use most often, because guess what? Most events in life are not mutually exclusive. There's going to be some crossover, some overlap. Okay. So like I said, if event A was the probability of you having 6th block PE, and B is the probability of you having 7th block history class. Now, no one in here is in that category, or you might be in this category for 6, right? If you have PE 6, you might be in that category. But then let's say I also have 7th history, then I'm also in that category. Well, I counted you twice, so that's what we have this subtraction for. Okay. If you fall in one or the other, you can't be an and. And means both, right? And means it has to be both. Okay, so this is the one we're going to use today, probably tomorrow the most. Okay, here's the nice thing. You don't have to memorize it because it's going to be given to you. There's a formula sheet that they'll give to you on the day of the test, on the day of the AP test. It's a formula sheet. It's got 2 sides. I'll make a copy and give this to you tomorrow. This one here is on it. I haven't given this to you yet because chapters 1, 2, 3, and 4, the formulas they give you for chapters 1, 2, 3, and 4 are useless, because I would not, for these formulas here that they give you, I'll show you more tomorrow. These formulas they give you for 1, 2, 3, and chapters 1, 2, 3, and 4, I would never do it by hand. I would only use the calculator to do them because it would take you way too long by hand. So that's why I haven't given them to you yet, because we've used the calculator. But now we're going to have to use more formulas. So the rest of the chapters that we're going to do will be here, and I'll give you one tomorrow. Okay. Okay. We talked about independent and dependent events. Whoops, what happened? We talked about independent and dependent events. Okay. The outcome independent. The outcome of one does not affect the other. Mutually exclusive. Disjoint. Sometimes they're called disjoint. Disjoint is the same thing as mutually exclusive. If they're disjoint, they don't have any outcomes in common. They can't happen at the same time. No one can do both. Okay. No one can do both. You cannot be in this class and be in English class at the same time during 7th period. It can't happen. Okay. Throughout this chapter, here's the thing about this chapter. This chapter is kind of weird because the math is some of the easiest math you'll have in all this class. It's very easy math. Did you see the math up there? Adding, subtracting, multiplying, dividing. Very easy math. It's not high level math. But the problem with this chapter that students have is that it's a lot of critical thinking. You're going to be kind of out on a limb and you're going to kind of be like, okay, what's my next step? What's my next step? Make sense of it, right? So these are the 4 things we're going to do to make sense of it. If you don't do one of these 4 things and you're stuck on the problem, you need to try one of them, if not multiple ones. One way is two-way tables. Two-way tables. We've seen two-way tables. They kind of look like this. They kind of look like a tic-tac-toe thing where we have numbers in them. Two-way tables. I have a variable up here and a variable on the side. We've seen things like that already. One way is if they don't give you one of those, make one. The second one is a Venn diagram. You guys have all seen Venn diagrams before, not in this class, but Venn diagrams of 2 circles with some overlap. It helps. Trust me, these things help. They seem very childish to do, but trust me, they help. If you can visualize it, it's a lot easier to do these problems. Another one, which we'll talk about later in the week, is a tree diagram, right? Starts out branches, and then it branches off, and then branches off. Those help a lot too. And the last one is using those formulas that we just looked at. Okay, using those formulas that we just looked at. The key in this chapter is to making everything as simple as possible. The math is always going to be easy. You're just adding things, subtracting things, multiplying things, division occasionally. But sometimes it's hard because you're like, what do I add? What do I subtract? Keep these things handy. Anytime you get stuck, try one. Sometimes it's easier to use a Venn diagram. Sometimes it's easier to use a two-way table. Sometimes it's easier to use a tree diagram. Sometimes it's easier to use formulas. Sometimes it's easier to use 2 of them. Whatever's easiest. Okay? Because I can't say that you're always going to use a table. You're always going to use a diagram. You're always going to use a tree diagram. It just depends on the problem. Okay? So that's mainly my job for this chapter, is to give you as many different problems, give you as many situations as you can. Okay? So that you can kind of get the hang of what to look for. All right. Okay, so let's start with the first one, the marbles problem. Marbles. Okay, so we have a bag of marbles. In the bag, there are 10 red, 12 green, 15 blue, 8 yellow, 12 white, and 7 of them are black. Okay, so the first one, they want to know what's the probability of red. Okay, so when I'm solving these, I want to label. You make sure you label so that you know what you're talking about. So the probability of red, we can write like this. The probability of red. That says probability of red. Capital P, red in parentheses. Okay? So what is the probability of reaching in there and randomly picking out a marble? What's the probability of me pulling out a red? Definitely 10, because there's only 10 red in there. What are the total number of outcomes? What are the total number of things that could happen if I pull out a marble? 64? Okay. Always reduce your fractions if you can. So 5 out of 32. Fractions are okay. Decimals are okay. Percents are okay. So as long as you know how to convert, 5 divided by 32, we always go 3 spaces. So that one's good, or that one's good. Okay. If you know how to convert them, and if I wanted to, what percent would that be? 0.156. What percent would that translate to? 15.6%. Good. As long as you can do that, you are fine. Most of the time, decimals are what they want. But like I said, either one of those is okay. So the next one, what is the probability of me reaching in there and picking out either a blue or a white one? So I'm only reaching in once, right? Sorry, not a blue, a black. Oops. So this is what they're asking. A blue or a white one. A U means or. Well, hey, that one looks familiar. This one looks familiar. This symbol looks familiar. Don't I have a formula that goes with that? Right there. So the probability of one plus the probability of the other, subtracted any overlap. So the probability of black plus the probability of white minus any overlap. Black and white. All right, so what's the probability of reaching in there and pulling out a black marble? Say 7 out of 62? 7 out of 64? Okay. Plus, what's the probability of reaching in there and pulling a white one out? 12 out of 64. Minus any overlap. Are there any overlap black and white, meaning black and white marbles? No. They're mutually exclusive, right? You can't reach in there and pull out a black and white one. You're either going to pull out a black or a white or something else, right? So we add them together and we get 19 out of 64, which is the same thing as
0.296.
Yep. 29. We round 297. Yeah. Almost a 30% chance. You pick out a black, you pick out a white, or you pick out both. But in this case, there are no both. So that's why that was a 0 there. The 0 was from both. Okay. Red or green? Red or green. So the probability of red or green. So I'm going to start using letters instead of some. You can do this as well. Red or green. Well, it's the probability of red plus the probability of green minus any overlap. Overlap is and. Okay, so what's the probability of a red? 10 out of 64 plus the probability of a green? 12 out of 64. Is there any overlap here? No overlap because you can't get a red and a green one at the same time. So we add them together and we get 22 out of 64, which is the same thing as
0.344.
there you go. Yeah, 11 over 32. So yeah, fractions are okay. So if you have a fraction, make sure you reduce it, but fractions are okay. Yes, that's okay. 34.4%, that's okay. Yeah, like I said, on multiple choice, on free response, it doesn't matter because there's no options. But on multiple choice, most of the time they're in decimal. They're just as decimals. They're not as percents. They're not as fractions. So that's why I tend to leave them as percent or as decimals. But you can change them for 2%. That's okay. Nothing wrong with that. Yes. Yeah. Yeah. They're in the back right there. Just in the blue bin. Should be the first one in the AP Stats folder. All right, so now the probability of red or the probability of green or the probability of blue. So now we got 3 probabilities here. So I'm going to find the probability of red, add that with the probability of green, add that with the probability of blue, and then I'm going to subtract any overlap. Overlap is all of them. Red and green and blue. Okay. Now I'm writing them out because A, this is their notes, and B, I just want you to be able to refer to it later on why I got those numbers that I did. It's good habit to write things out because it's a roadmap to what you're doing. First thing you're going to do is find the probability of red. We already did that. Probability of green, didn't we just do that too? 12 out of 64. Probability of blue, I don't think we've done that one before. What's probability of blue?
15 out of
15. And then there's no chance of overlap on this one because there's no chance of me getting a red, green, and blue marble. So what is that? 37 out of 64. Which is 0.578. Okay. Okay. What's the probability of not white? That's how I would write it as a symbol, not white. So if it's not white, it's going to be every other color, right? So just add up all the other colors. How many? Or just subtract it. You can subtract the whites or add up all the other colors. 52. There are 12 whites. So every other color would be 52 out of 64, which is, let me reduce that. 52, 13 out of 16, which is the same thing as 0.813. Okay, so the last one is a little tricky. Not white. Okay, the probability of or. So is it going to be not black or just regular black? See, what I see is not white or black. I don't see not and not. See what I mean? Because there's a difference between not white and black or not white and not black or not, you know what I mean? So you just got to be careful. I would see, I don't know. I would put nor, like if not white nor black, right? So you just, so what I see is a not white or black. Okay. So that's going to be the same as the probability of not white, which we already know, plus the probability of black minus the probability of both of them. Okay. Well, we just did this one. Probability of not white is 0.813. Probability of black, we did earlier, right? No, we haven't. Yeah, we did. 7 out of 64. Probability of black is 7 out of 64. 7 divided by 64, which is 0.109. Minus, is there any overlap here? Not white and black. Which ones are that? Which ones fit into that category? Yeah, the blacks, right? Aren't the black marbles, aren't the black marbles not white? And they're definitely black, right? So the overlap are the black marbles, which we know right here. So these two guys just cancel each other out. So instead of saying not white or black, they could have just said not white.
So it's the chance of not getting a white and not getting a black.
No, the chance of not getting a white or getting a black. That's the probability I found. Yes, that's what I'm saying. The wording is tricky. It's not the problem that's tricky. That you guys can do the math. It's just adding and subtracting. We got the formulas, but the wording sometimes is tricky. Okay. All right, let's try this problem here. Actually, you know what? Try these on your own. Similar problems. So do number 2, 2A through F on your own, and we'll go over them in like 10 minutes. I did the first two. Probability of a new show. There's 7 new shows, 120 stations total. So the probability that you randomly select a new show, there you go. Probability of a commercial. There's 42 commercials currently on at that time at 8 o'clock. So 42 out of 120, 0.35, about a 35% chance that you're going to randomly, if you randomly turn it on, you know, like Netflix now has a random thing, so you can hit the random button and it randomly gives you something that to watch. That's the kind of idea. Um, comedy or drama, comedy or drama. Okay, so comedy, probability of a comedy is 13 out of 120. So 13 out of 120. Probability of a drama show is 12 out of 120. Probability of a comedy and should be and. This should be and. Well, there are no comedy drama shows that they said listed. There was nothing listed there, so that would be no um, overlap. So you get 25 out of 120. Which is 0.208. Probably should have reduced that, but I ran out of room, so. Okay. The only time you don't have to reduce reduce fractions is when you change them to decimals. If you're going to leave it as a fraction, make sure it's reduced. Okay. Sports, movies, or news. Sports, 18 out of 120. Movies, 25 out of 120. News, 7 out of 120. There are no sports, movies, news channels. 18 plus 25 plus 7 is 50 out of 120, which is 0.417. 0.417. Okay. Not a sales program. Not a sales program. So that means everything else. So we're going to take 1 minus all of the sales programs. So you can either count everything that's not a sales program, or you can just count the sales programs and subtract them from the total. Well, there's 120, and there are 3 sales programs. So that's 117 over 120. Which is 0.975. Okay. The last one, the not sports. So neither sports. Oh, okay. So I read that wrong. Since they use neither, it should be M. Yeah, it should be both. Yep. Yeah, I just read that right now. So this should be a C by it, and this should be a C by it. There we go. Okay. So not a sports. So not a sports. Well, sports accounts for 18. So 18 away from 120 is 102. Not a movie. Not a movie. How many movies are there? 25 movies. So not a movie would be 95. Minus any not sports, not movies. So which ones would that be? Not sports and not movies. And yeah, overlap. I'm looking for overlap. I'm looking for stations that were included here and here.
Movies and sports.
So it has to be not sports and not movies.
Well, the sports one already counts for movies.
Yes, exactly. So yeah, so not sports, not movies would be commercials would count. News shows, comedy shows, drama, sales, everything else except those two. So those account for what, 43? 43, so minus 43. So 120 minus 43. That's 77 out of 120. So 102 plus 95. Those are the overlap. Oh, wait. No, no, sorry. I did the wrong one. Yeah. So this one right here, not sports and not movies. Wait. Not sports and not movies. That's right? 42 plus 7 plus 13 plus 12 plus 3, right?
I think you're supposed to subtract 43 from 120 at the beginning. So it's not 102, it's 80 something. I think.
So the first number is everything that's not a sports show, right? So that's that's just the sports shows, 102. This guy right here is everything that's not a movie. Wait, no, I think I did this right. I think watch when we're done. I'll
Wait. When you count not sports, don't you also count movies? In
exactly. So
you would subtract by 18 and 25.
no, this is right. What happens is what we get 120 out of 120,
Right.
which is equal to 1, right?
Um,
So the chances that you pick neither a sports movie or a movie, or sports or a movie, is 100%.
right.
That's what it's saying. You're going to choose one. Guaranteed you're going to choose one.
All right.
Because it's one or the other, right? It's not one or the other, right? I can't choose a sports in the first one, but I can in the second one, and I can't choose a movie in the first one, but I can in the you know what I mean? So like that's why it's one hole. Okay. All right. So tomorrow, or remember, there's an assignment due tomorrow. Okay.